In this lesson, we're going to look at how to solve trig equations. So 6.2. So what are trigonometric equations? Basically, they're equations that involve trig expressions. So just like we used to have equations where we would have like x plus 3 is equal to 7, right? Where this does not have a trig in it. Now all of a sudden we're going to replace the x with some sort of trig expression where we'll solve for our answer, and then we'll have to take what we learned in the previous section in 6.1 and apply our inverses. We are going to assume all of our answers are in radians unless we specify. Again, that's just the universal mode where we're always in radians. Okay. Now there are three types of equations that we are going to see. All right. The first type we call the identity, aka they're always true. Now we've seen these types of equations before, where we said like x plus 3 is equal to x plus 3. I can plug in any value in for x, and I'm going to get the right side equal to the left side. So when we deal with them in terms of our trig, we're going to see something like this. So sine squared of x plus cosine squared of x is equal to 1. X will be able to be anything, or maybe it's a double angle. So cosine of 2x is equal to cosine squared of x minus sine squared of x. Again, x will be anything as long as it's in the correct domain. Something that's inconsistent. Again, something that's never true. If I say x plus 3 is equal to x plus 2, right? When I end up solving for this, my variables always cancel out, leaving me with 3, oops, not 3 minus 3. 3 is equal to 2. That we know is not true. And so there will be never any number I'll be able to plug in for x to get the left side equal to the right side. So something that might happen is if you have something that looks like this, sine of x is equal to pi, right? This is never true because sine of x is somewhere always between 1 and -1, and pi is about 3.14. So we know that it's way outside of the number 1, right? Or aka cosine of x is equal to -2. Again, this will never be true because, again, cosine is somewhere between -1 and a +1. Okay? Now, most of our equations that we've always dealt with are always the conditional. So that's where the majority of our trig equations are actually going to be. So they are sometimes true. So if I solve x plus 3 equal to 7, this is sometimes true when x is equal to 4, right? There are no other numbers that this is going to work for. So all of our problems here are going to be in this region. So say I have sine of x is equal to 1, right? Well, x is going to equal pi over 2, or aka 90 degrees. Again, we're going to assume it's always radians unless specified, right? If I say the tangent of x is equal to 1, right? Now I have two answers, right? Pi over 4, and in the third quadrant, 5 pi over 4. So again, as long as it's inside our region, we'll actually learn that this actually only has one answer, and it's pi over 4. This is just a repeated answer. But again, that is for later on in our video. So this is where the majority of our problems are going to be on. But again, it's important to recognize if we ever have an identity or if something just kind of doesn't make sense. Okay. Now, there are two ways that we can write our solutions to these problems. The first one is we're going to find all of our solutions to the equation within 0 and 2 pi, or 0 degrees and 360. Right? So if we come back to the first problem, this is between 0 and 360, or 0 and 2 pi. Technically, then this would have two answers if I said between my 0 and 2 pi. Or sometimes we want to find every solution out there. And that means that we're going to find them within one period, and then we're going to add all integer multiples of our period. Okay, and it's important to recall what a period length is. For tangent and cotangent, the period is pi. For everything else, sine, cosine, and its two reciprocals, our period is 2 pi. So again, that kind of brings us back to a little bit of the graphing aspect. All right, so I have a couple different ways that we can solve. So our first one is called solving by linear methods. All right, linear because there's going to be no exponent. And so I have a couple of steps and tricks that we should be using. The first thing you want to do with any problem is you want to isolate the term containing that variable. All right, that's the first thing that we want to do. And then the second one is figure out how to solve for it. So solve for the variable. All right, so again, pretty straightforward what we have to do. All right, so let's do our very first example for this page. Okay, so find all exact solutions in radians. All right, so here's our problem. 2 cosine x minus root 3 is equal to 0. So the first thing I'm going to do is I'm going to isolate. So I'm going to add root 3 to both sides. So if I do that, I'm going to get 2 cosine of x is equal to root 3. I'm then going to divide that by 2. Divide that by 2. I'm going to get cosine of x is equal to root 3 over 2. So now what I want to do is I want to figure out where am I going to get root 3 over 2. So I know I'm looking in quadrant number 1 and quadrant number 4 because again the period length is going to be 2 pi. So that goes to all my quadrants. Okay, so in quadrant number 1 I know that x is going to be pi over 6. And in quadrant number 2 I know the answer is going to be 11 pi over 6. Again, we're using that from our unit circle. So how do I actually write all of my answers? Because if you recall, right, if I have pi over 6, right, so here's pi over 6, I could just have this answer, or I could go all the way around and then add another 2 pi. So I can say plus 2 pi, or aka this would be 12 pi over 6. So that means it would be 13 pi over 6. And then if I wanted to add another, if I want to go around again, so what happens if I went around, I kept going around a little bit more, so I added another 2 pi, so now I'm at 25 pi over 6. I don't want to keep writing out all of these answers. So what I'm going to do is I'm going to write two equations. I'm going to say x is equal to pi over 6 plus n times 2 pi. Okay, and then for my second equation, I will say 11 pi over 6 plus n times 2 pi. So here, we're just paying attention. N is the multiples. Right? So when I said the integer multiples of the period, right? So n is that multiple. Okay? So again, all of our numbers for right now are going to be consistent. And we do want to check, we want to make sure if this is actually true. So let's check this answer out. So, so again, here's our quick little check. So 2 cosine of x minus root 3. So let's check pi over 6. So 2 cosine of pi over 6. So that are equal to 0. So this would be 2, and then this would be root 3 over 2 minus root 3. The 2's will cancel out, leaving you with root 3 over root 3. And when you subtract it, you get 0. So now let's check. So that's that one. Let's check 11 pi over 6. So 2 cosine 11 pi over 6 minus root 3 is equal to 0. So again, This is going to leave me with this, which ultimately brings me back to that problem, which leads me there, which leads me to 0. All right, so again, it's important to always check all of our answers. All right, let's go ahead and try another one. Let's do it in degrees this time. So find all exact solutions in degrees. Okay, for this problem, tangent of x plus 2 is equal to 3. So this is our second example. All right, so I'm going to go ahead, I'm going to subtract 2 to both sides, and I'm going to get tangent of x is equal to 1. Wonderful. If I think about this, again, the period is only for tangent, it's only pi, so I'm only dealing with the first quadrant. I want it in degrees, so x is 45 degrees. So my answer will be 45 degrees plus n times my period length, 180. So again, if I went around 45 plus 180, right, I'm going to get the 225 degrees, which again would be my third quadrant, and then I could add another I'm sorry, not 45, sorry. I can add another 180, and I will be right back into my first quadrant, right? So, so it should be 405, and then I'll add 100, so I'm bouncing right back and forth between my first and my third quadrant. So again, here's my 45 degrees. There's my first period. My second period kind of rounds it off in here. So bam. So I'm just going to keep adding 180, 180, and just going to keep going around and around in a circle. Okay. Again, we want to check our solutions. All right. There is another type. So what about this type? Solve by factoring. Okay. So again, we have 3 steps. Biggest thing is make sure the equation is set to 0. Actually, let's say set equal. Let's rewrite that. Set equal to 0. And then we want to factor. So factor completely, whatever that means to you. And then finally set each factor equal to 0 and solve. All right, and again, we want to make sure, check all answers. It's a good habit because we are going to see some problems where we will, when we check our answers, it's not going to give us an answer. So when we come back in part 2, we'll start with some examples on factoring.